Welcome back, and in this series of videos we're going to be looking at redox, that is oxidation and reduction reactions. So originally oxidation was defined as the gain of oxygen or the loss of hydrogen, and reduction is the other way around, the loss of oxygen or the gain of hydrogen. So for example, this would be a classic redox reaction where the copper is losing oxygen and the hydrogen is gaining oxygen. So in this case, it's the hydrogen which is being oxidized because it is gaining oxygen, and it is the copper oxide which is being reduced because in this case it is losing oxygen. However, it soon became apparent there were a large number of reactions which didn't involve oxygen or hydrogen, but were very similar. So if we consider the second example, copper 2 chloride reacting with magnesium, you see that you've got an element going to a compound and a compound going to an element. In the same way you have here. So you have the copper going from the compound to the metal element, and you have the hydrogen going from the elemental form to a compound. So in the same way as we have before, the substance being oxidized would be the magnesium, which is taking the place of the hydrogen, and the species being reduced is the copper 2 chloride. What is actually going on is a movement of electrons, and that is how we now define oxidation and reduction. But the name oxidation is stuck even though there is no oxygen involved. So nowadays we would say oxidation is a reaction where a species loses an electrons, and reduction is a reaction where a species gains electrons. And we can remember this by using the acronym OIL-RIG. Oxidation is loss, reduction is gain. From our group 2 work, we can remember that magnesium and oxygen react together in a nice simple equation. So magnesium and oxygen react to form magnesium oxide. I can balance it by putting a half in front of the O2, or I could double everything up and put 2 in front of the magnesium and the magnesium oxide. So I have solid magnesium, gaseous oxygen reacting to form the ionic compound magnesium oxide. So the magnesium is going from its elemental form here, which has no charge, it has, we say, an oxidation number of 0, to the magnesium compound where the magnesium now has a charge of +2. So in terms of electrons, the magnesium has gone from having all of its electrons to losing 2 of them to become a 2+ ion. So it's lost 2 electrons. Each of the oxygen atoms on the other hand has gone from its elemental form here. Oxygen, it's got all its electrons, so it's an uncharged species, but here it's formed the oxide ion. So each oxygen has gained 2 electrons. We can write the oxidation half equation showing the electrons being lost. So the magnesium is losing its electrons, so it's going from magnesium to magnesium 2+, and it's lost 2 electrons. Now it's important that these equations still balance. So that is not only to do with atoms but also with charges. So I have no charge on this side and I have no charge on this side. The reduction equation on the other hand is my oxygen. So I'm going to start with half O2, and each oxygen gains 2 electrons to again become O2-. Now these are what we call half equations because they don't show the whole picture. These reactions cannot occur on their own. It's only when we combine them that we get the redox reaction. So when I combine these two, we go back to our original equation. Another example of this, again starting with magnesium, this time reacting with chlorine gas to become magnesium chloride, MgCl2. So the magnesium atom again is going from this neutral magnesium element to the magnesium ion in the compound. So again, it is losing, or it's lost 2 electrons. Each chlorine atom Well, it's going from chlorine in its uncharged elemental form here to a chloride ion, each of which has a -1. So each individual chlorine atom has gained 1 electron. So this again is an example of a redox reaction. Again, if we look at the reduction and the oxidation half equations, well, the chlorine is being reduced. So we're going to start with that. So I'm going to do the whole thing. So the chlorine is going to go to 2 chloride ions, and obviously it is gaining 2 electrons, again making sure it charge balances, and the magnesium is losing 2 electrons. And when we combine those two equations, when we add them back together again, the electrons will cancel and we'll get back to this equation. Another reaction which you may be very familiar with from GCSE is the displacement reaction of zinc with copper sulfate. So again, we start with copper sulfate, CuSO4, and elemental zinc. They're reacting together to form zinc sulfate, SO4, and elemental copper. Now, the SO4 is what we call a spectator ion. In other words, they don't take part in the reaction. Just as you would eliminate them in an ionic equation, you also eliminate them in half equations as well. So the reduction half equation would be my copper, because my copper is going from 2+ in the compound here, and it's gaining 2 electrons to produce metallic copper. In other words, it's been reduced. Whereas the zinc is being oxidized. The zinc becomes zinc 2+ plus 2E negative. And if you add those two back together again, you get back to this equation minus the spectator ions. Another typical type of question you might be asked is given an equation and you have to work out whether or not it's a redox equation. Well, here, very simply, you're looking at the copper species. Well, the copper is going from an element to a compound, so therefore it's going from 0 to +2. So that's going to be my oxidation reaction, and the silver is part of a compound here as +1, and it's silver metal here, which is 0, so that's my reduction. So yes, this is a redox reaction. Again, we ignore the spectator ions. In this case, it's the nitrate ions that are spectator ions because they don't change oxidation number or charge, and they don't change state. So again, we can ignore those and we can just do the reduction half equation. So the reduction half equation is my silver plus gaining an electron to become silver metal. So I should put the state symbols on that. And the copper is being oxidized because the copper is going from copper metal, solid, going to Cu 2+, which is part of solution, and it's losing those 2 electrons.